Welcome friends. Today I will discuss about non-inertial frame. We have discussed in the previous lecture that Newton's law holds in the inertial frame of reference, but there are another frame of reference which is known as the non-inertial frame of reference. Now what is non-inertial frame of reference? Non-inertial frame of reference is an accelerated frame of reference with respect to a fixed one. This is the non-inertial frame of reference. Very often we come across problems in physics, the solutions of which can be readily obtained if we employ moving coordinate system, the frame of reference. In such problems we usually consider two frames, one which is fixed and the another which is moving with respect to this fixed frame. The fixed frame is considered in the laboratory and the another frame is moving with respect to this fixed frame. Now the moving frame of reference in general can possess translational and rotational motion relative to the fixed frame of reference. A frame of reference moving with a constant velocity with respect to the fixed is known as the inertial one, and the frame of reference which moves with an acceleration with respect to a fixed frame is known as non-inertial frame of reference. Now in case of non-inertial frame of reference, there is another force which is known as a fictitious force comes into play. If we consider the following picture, y dash, z dash, o dash, x dash, and another frame which is here z, this is y, and this is x. This is origin O. Now the position vector of its origin with respect to the origin O dash is capital R vector, say, and a particle is located at this point, say P, the position vector of which is R vector with respect to the origin O. The picture is so clumsy. Now we will draw a fresh picture. This. Now the particle is located at P point. This is the this is the point O, this is the point O dash, this is Y. This is the position vector of the point O with respect to the point O dash, which is the origin of the fixed frame x dash, y dash, z dash. And this is y, this is z, this is x. The position vector of the P point with respect to O is smaller, and the position vector of P point with respect to O dash is R dashed. Now from triangle law, R plus R is equal R dashed. Therefore r dot, the dot sign implies d at dt. R dot plus small r dot is equal r dash dot. Similarly, if we again the differentiate with respect to time, then we will get r double dot plus r double dot is equal r dash double dot. Now the frame, in case of inertial frame, this frame moves with an uniform velocity with respect to the fixed one. So for this case r double dot will be 0 and r double dot will be equal to r dash double dot. From this m r double dot is equal m r dash double dot. So Newton's second law holds good for inertial frame. But in case of non-inertial frame, r double dot exists since it is an accelerated frame with respect to this fixed. So r double dot exists. R double dot plus r double dot is equal r dash double dot. So m r double dot plus r double dot into m is equal am r dash double dot. So this is f naught plus f is equal f dash. Let m r double dot be f and m r dash double dot be f dash and m capital R double dot be f naught. This is the extra term which arises and which is different from the inertial case. This is known as the fictitious force term. If we have to equal f and f dash, then we have to minus some f naught term from the left hand side of the equation. This f naught term is known as the fictitious force, which is related only to non-uniform frame of reference. This is the non-uniform frame of reference. Sorry, non-uniform. It is not non-uniform, it is non-inertial frame of reference.